final velocity minus initial velocity. Okay. For example, suppose a person is moving from A point to the B point in a straight line. The person is moving from A point to the B point. So at point A, this person have the velocity small u, and at point B, this person have the velocity small v, and time taken by the person to reach from A to B is this t. Okay, so this is the initial point, so this will be the initial velocity. This is the final point, so this is the final velocity. What is the change in velocity? Final velocity minus initial velocity. So final velocity minus initial velocity divided by the time t. Okay, so this is your acceleration.
Okay.
Okay, so this is your acceleration, and one more thing you should remember: your acceleration is a vector quantity. Okay, your acceleration is a vector quantity. Okay, so now uniform acceleration. Uniform acceleration. Uniform acceleration means acceleration is not changing with time. Means acceleration is constant. The body is moving with same acceleration. For example, a person is moving from A to C, C to D, D to B. Means finally the person, initially the person is at A, finally the person is at B. Okay, at A, the velocity of the person is 10 meter per second. At C, 20 meter per second. At D, 30 meter per second. At B, 40 meter per second. If you will calculate the acceleration of the motion from A to C, C to D, D to B, you will get always 2 meter per second square. So here from the motion A to B, the acceleration is not changing, means acceleration is constant. Acceleration is not changing means acceleration is constant, and this constant motion with constant acceleration is also known as the uniform acceleration. Okay, or uniformly accelerated motion, or uniformly accelerated motion. After that, I have told you the equation of motion. So we have three equations of motion. Three equations of motion. And these equations of motions are valid when the acceleration of the body is constant. Okay. When the acceleration of the body is constant, or you can say uniform, or you can say acceleration is not changing with time. This is the case. Okay. As here the acceleration is not changing with time. So V is equal to U plus AT is first equation. S is equal to UT plus half AT square second. V square is equal to U square plus 2AS third equation. Okay. So basically, what is this B? Final velocity. V is the final velocity. I have written all the things, and I have already told you in the last class. What is U? Initial velocity. What is A? Acceleration. What is T? Time. What is S? S is the displacement. Okay. S is the displacement. Okay. Okay. After that, we have done this numerical. So basically, these are the equations of motion. Now, we were discussing the motion under gravity. Motion under gravity we were discussing. So basically, what is the meaning of the motion under gravity? So I am giving one simple example, motion under gravity. The falling of this pen is an example of motion under gravity. The falling of this pen is an example of motion under gravity if I consider that there is no air around this pen. Okay.
Yeah.
So basically, I have told you motion under gravity is also known as free fall. Why it is known as free fall? Because the body is falling freely. Because the body is falling freely. Okay. There is no any other force other than the gravitational force. Other than the gravitational force, there is no other force. Okay. And we are not considering the air, so there is no air friction. Okay. So this is the body, this was the body, and this body is falling in downward direction. So in this case, when the body is falling, like this, you can take this example, this falling of this pen. So when this pen is falling, the acceleration of this pen will be 9.8 meter per second square. That is known as acceleration due to gravity. That is known as acceleration due to gravity. So acceleration due to gravity will be in downward direction. Okay, and as the body is moving in the downward direction, so the gravitation force is in the downward direction. So acceleration due to gravity is in the downward direction. Okay, so motion under gravity is again an example of uniformly accelerated motion. So basically, equations of motions are valid here also. We have three equations of motion. V is equal to u plus at. Second, S is equal to ut plus half at square. Third, v square u square plus 2as. Okay, these equations of motions are valid for motion under gravity. Okay, so you can write these equations are valid. Valid means we can apply and we will apply this equation of motion for motion under gravity. So these equations are valid for motion under gravity. Okay, but here we will use sign convention. Here we will use sign convention. Sign convention means negative or positive sign we will decide here. Okay, sign convention. So see what is sign convention. Okay, so I am telling you what you have to do in sign convention. Suppose a body, if a body is moving in upward direction. So basically what you will do, this direction is the upward direction. Which direction? Upward direction. Upward direction. And if this direction I am taking, this is the downward direction. Downward direction. This is the downward direction. So you can choose any of the direction as positive direction. You can choose any of the direction as the negative direction, depending upon you. But we will choose upward direction as positive direction. And we will choose downward direction as negative direction. Okay. After that, suppose I have thrown, for example, this is the pen, and I have thrown this pen in upward direction like this. Okay, like this. I have thrown this pen from this point like this. I have thrown. Suppose a person is throwing a ball from the ground. So suppose this is the ground. This is the ground, and a person is throwing a ball from the ground. This ball will go in upward direction like this. This is the ball. So basically this ball is going in the upward direction. Okay, this ball is going in the upward direction. So what will be the displacement of this ball? Suppose at initially this ball is initially at A, finally this ball is at B. So what will be the displacement? This will be the displacement. This AB. AB will be the displacement. This. Okay. So this will be the displacement. Actually, this will be the straight line. This will be the straight line. Okay. So this ball is going. This displacement is in upward direction or downward direction?
Upward.
Upward. So in upward direction, we will take displacement positive. Okay, because upward direction I have considered as positive. So in this case, we will take here displacement. S is the displacement now. I have told you S is the
Yeah.
displacement. We say S for displacement. So displacement in this case will be positive. We will take displacement positive. Suppose the ball is covering from a ball is covering a displacement of 10 meter. So in that case, when we will use equation of motion, so we will take that 10 meter as positive. Okay. Okay. So after that, in the same way, the velocity, initial velocity of the ball will be in upward direction. Okay, because the ball you are throwing in upward direction, so initial velocity also you will take positive. Okay, and during the motion of this ball, there is one more term, acceleration due to gravity, G. I have told you this G. I have told you this will be the case of motion under gravity, throwing of a ball in upward direction. So acceleration due to gravity in free fall or motion under gravity is always in downward direction. Or you can say this on this ball the acceleration will be in downward direction. So acceleration due to gravity you will take negative. You will take negative. Okay. Now you can take another example. Suppose this is the ground. Suppose this is the ground. Oh, this is the ground, and a ball is going in downward direction like this. If this is the condition, so finally this ball will be at the ground. So this is the initial point of the ball, and here somewhere will be the at this ground there will be the final point. So you can say the displacement of the ball is in downward direction. This time displacement is in downward direction, S is in downward direction. So in this case you will take displacement negative. Okay, and this ball will be some velocity in downward direction. So this time you will take initial velocity also as a negative. And I have told you G will always be in downward direction. G means acceleration due to gravity will always be in downward direction, and this in downward direction. So we will take this as negative this time. Okay, so final velocity will be also in downward direction. Finally, the ball will be at point B. Okay, so final velocity will be also negative. We will take. Why I am telling the sign convention? Because we will use these equations of motion, and we will use all the terms in this equation of motion, in these equations of motion with sign. Okay. Now I will take the example, then you will understand it properly. Okay, so take for example, a body dropped from some height. From some height h. Small h is the height. For example, you can take this body, you can consider this body, and this, I am just dropping this body. Dropping means this is the case. Dropping is this, like this. Okay, this is the dropping.
Yeah, okay.
Like this. Okay, so a body is dropped from some height. So what will happen? Okay.
The displacement will be negative.
Hmm?
Will be a negative displacement.
Yeah, you are right. You are right. Very good. Very good. So suppose this is the ground. So body is dropped from some height, from suppose from here. So this body will go in downward direction. Okay, like from here, this body will go in the downward direction. And from what height this body is dropped? From height h. This small h, this body is dropped. Now, this is your question, not your answer. What you want, what you have to calculate. Number one, time taken. Y body to reach the ground. Okay, and second, velocity of striking with ground. So velocity of body striking with the ground means you can say with what velocity the body will strike the ground. You can say with what velocity the body is striking the ground. So we have this data. A body is dropped. This is your body, suppose. And this body is dropped from height h, and we have to calculate time taken by the body to reach the ground and velocity of striking with ground. This we have to calculate. Okay, so what we will do? First thing, when we dropped a body, okay, when we dropped a body, always the initial velocity of the body is zero. See this pen, I am just dropping this pen. Initially this pen has velocity or not? There is no velocity. This pen is at rest. Initially this pen has no velocity. If I am dropping this pen, not throwing this pen like this, I am dropping this pen. So basically initial velocity in this case is zero. So your initial velocity is represented by small u, 0. Okay. Now what will be the displacement? With sign convention. What will be the displacement? Body is going in downward direction. So displacement will be in downward direction. So you will take minus h.
Yeah.
Okay. We will take minus h because body is in the downward direction, so displacement will be in the downward direction, and downward direction we take negative direction. Okay, very good. What will be the acceleration of the body? Minus g. Okay,
Okay.
acceleration will be minus g because this is the case of the free fall. This is the case of the free fall. So minus g. Now we want to calculate the time, and we have these three equations. So which equation I should use to get the time? So see, in this equation there is time. This is time, na? This small t is representing time. So in this equation there is time. So there can be the possibility with the help of this equation we can get the time. And there is one more equation in which the time is there. We cannot use this equation because we do not have time right now. We can use this equation, but right now we cannot use. Now we will check, we will use first equation or not. In this we have this v. This, what is this v? This is the final velocity, and we do not have the final velocity, so we cannot use this equation also. So we will use this second equation. Get it? So we will use this equation. S is equal to ut plus half at square. So now put the value of s minus h. Initial velocity is 0. Okay, instead of this u, you will put 0 because this initial velocity is 0, and t is the time multiplied by t plus half acceleration. This is your acceleration. Acceleration is minus g. This is minus g, and this time we have to calculate. Okay, so I am considering t is that small t is the time taken by the body from here to here, time taken by the body to reach the ground, or you can say time taken by the body from here to here. So this time we want to calculate. So I can write this as minus h. This will become, this is 0. This whole term is 0. So we can write this 0. And this is half. This is multiplied by minus g. This is t square. So I can write this minus half gt square. Okay, so I can write this minus h is equal to minus half gt square. This minus and minus will be cancelled out. Okay, and this 2 can be multiplied with h. So this will be 2h is equal to gt square. So from here we can find the time now. I can write this 2h by g is equal to t square. Is it or not?
Yeah.
Now we can take under root on both sides, square root on both sides. Okay, so the square root we will take on both sides, so we will get this as 2h by g. This thing, get it?
Yeah.
How I have calculated this t. So this will be your time taken by the body to reach the ground. This will be your time taken by the body to reach the ground, 2h by the g. And remember, this time is not depending upon the initial velocity and not depending upon the final velocity. Okay, because I have taken this here, I have taken that air friction as 0. Okay, so we have considered as air friction 0. Neglect. Okay, so we have calculated the time. Now in second part they are asking velocity of striking with the ground, or with what velocity the body is striking the ground. So here the velocity of the body is 0, initial velocity. Here there will be some velocity. Suppose this velocity is v. Okay, what is the velocity of striking the ground? Velocity of striking, you can see. Okay, now what data we have? We have the initial velocity. We have the initial velocity, that is 0. Final velocity, that is velocity of striking, we have to find. Acceleration we have minus g. Okay, acceleration will always be in the downward direction. Displacement we have minus h. Now there is one more term we have, time. What is time? 2h by g. Okay, we have the time now from here to here. We have calculated this
Yeah.
time taken by the body to reach the ground, means time we have. So we have three equations. We have three equations. These three equations. So see which equation I should use so that I can get the required data. We want to find this v. Okay, so this v is here in this equation, equation number 3rd, and v is here. So we will not use this equation here, because here there is no v. Okay, so you can use this equation or you can use this equation also. From both the equation you will get the answer. So I am using first this equation, v is equal to u plus at.
Okay.
V is equal to u plus at I am using. So this v I want to find. U we have 0, acceleration we have minus g, time we have this 2h by g. Okay, now I can write this equation as v is equal to minus g. Okay, actually what can I do now here? Do you know, if I have written like 2, okay, and this is here under root 4, this is 2 and this is under root 4, I can write, if I will take this 2 inside the under root, so this will become 2 square. This thing you should know. Okay, if this is 2 and I want to take this 2 inside the under root, so it will become 2 square. Why? Because if 2 square is under the root, then it will become 2. So both these concept I will use here. So basically here is minus sign. So basically this is, you will take this g inside this under root, so this g becomes the g square, and here we have 2h also, and in denominator we have g. So now what, we can cancel out g square with g. What is the meaning of g square? What is the meaning of g square? You will multiply g 2 times, na?
Yeah.
Okay, and when you will divide it with g, so you will have only 1 g. So basically what you will have, this 1 g will cancel out with this, so this will become minus of under root 2gh. Okay, so minus of under root 2gh. So what this minus sign indicates? What this minus sign indicates? This is indicating that the velocity of striking is in the downward direction. So this will be your velocity, v is equal to under root 2gh. Okay, v is equal to under root 2gh. So your velocity of striking, you can write it 2gh also if you are 2gh, or you can write here direction downward. Got it?
Yes, sir.
Okay, so take the screenshot.
Okay.
Do you know how to take the screenshot?
Yeah, I know. Okay, done.
Done. Okay.
Okay.
Hmm.
Okay. Okay.
Hmm.
Okay, done. Okay. Okay, done. Okay, done.
Okay, now fine. Hmm. So this is the question. A ball is thrown vertically upward. A ball is thrown vertically upward with a velocity of 20 meter per second. Find the time of flight. Find the time of time of flight. Neglecting air resistance. Neglecting, I have already told you na.
Yeah.
Generally, we will neglect the air around the body. We will consider the motion only under the gravity. And this value of g is given as 10 meter per second square. So basically, a body is thrown upward. So just a minute. What will happen? We will take one pen. Okay, so see. Actually, if you are if a body is thrown upward in the upward direction, so what will happen? See, I am throwing this pen in upward direction. Okay, so this pen is going first in upward direction, then it is coming in downward direction. See, this is happening. If you will throw it, then it will come again in the downward direction. Got it now?
Yeah.
So first this is going in upward direction like this, like this, like this. Then for a moment this pen will be stopped here, and after that it will be coming in downward direction. Okay, now so a body is thrown, a ball is thrown. Okay, so here is your ball, and this ball is thrown in upward direction. Like this. This ball will go in upward direction like this. So initial velocity of the ball is given as 20 meter per second. Okay. This ball is thrown with the initial velocity of 20 meter per second. This is given in the question. A ball is thrown vertically upward with a velocity of 20 meter per second. Find the time of flight. So what will happen here? After some time, here the wall will stop, then after that this wall will come in downward direction. Okay, after that this wall will come to the downward direction. So we can draw it like in a better way like this. Okay, so after that, from this point, this wall will be in the downward direction, or finally this wall will be here. Okay, so what is the time of flight? Time of flight is basically time taken by the wall from this A point to this C point, if this is B point. Means time in going by the wall and coming to the ground again is known as the time of flight. Okay, time
Yeah,
of flight. Yeah, time of flight. So this time of flight we have to calculate. Okay, so initial velocity is given. This is very easy question. I will apply just one formula and in 30 seconds I can calculate the answer. Okay, remember one point, time in going from this and this point where the wall stopped for a moment, where the wall will be stopped for a moment is the highest point. Actually what is happening now, wall is going in downward direction and somewhere the wall will be at rest momentary. For a moment the wall will be at rest and after that the wall is coming. So from here to the point where the wall is momentary at rest is known as the highest point, and highest point, at highest point wall will be at rest. For a moment. So basically here the velocity of the wall will be 0 at this point. Here the velocity of the wall is 0 at this point. So suppose this is point A and this is point B. This is your point B. Okay. Basically this point and this point are same point. Okay. So A to B and B to C. So what is the time of flight? Time of flight is equal to time taken by the ball from A to B, plus time taken by the ball from B to A. Okay, A to B and B to A. And remember, time from A to B always equal to time from B to A. This thing you should know. Okay, both the times are equal, as it is given that there is no air resistance, so that is why the time are equal. So we calculate, we can calculate any of the time and we will get the answer. So I am just calculating the time from here to here. So when the ball is going from A to B, when the ball is going from A to B, what will be the acceleration? Acceleration is acting in the downward direction always. Okay, so for motion of ball from A to B, so A point is the initial point and B point will be the final point. So at A the velocity will be initial velocity, at B the velocity will be final velocity. So at A initial velocity is 20 meter per second at v final velocity, that is 0, and acceleration is given as minus g, and g value of g is given as 10. So acceleration is basically minus 10 meter per second square. Okay. So now we want to find the time now, so we can use this equation. V is equal to u plus 80. V is 0. V is 0 and u is 20. And I am taking this as plus 20 because from A to V the ball is going in upward direction. Okay. So this is 20. Acceleration is minus 10. And this time will be the time in going from A to B. Okay. So I can write this TAB. So basically this time we want to find. So we can find this easily. This will become minus 20. This will become minus 10 times 10 of TAB. This minus and minus will be cancelled out. So TAB will be 20 by 10. This will become 2 seconds. How we measure the time? We measure the time in seconds, in minutes, in hour. Okay. So here the time will be in seconds. So we know that TAB is equal to TBA. Okay, I have told you na, T from A to B and T from A to B is equal to T from B to A. So this is equal to 2 seconds. So now time of flight is this. Time of flight is TAB plus TBA. So TAB is also 2. This is also 2. So time of flight will become the 4 seconds. So this will be your answer. Time of flight will be 4 seconds. Another question. A body falls from a height of 45 meters from the ground. A body falls from a height of 45 meters from the ground. There is a point which is 45 meters away from the ground or higher from the ground. Okay. And a body is falling from that point. Find the time taken by the body to reach the ground. G is equal to 10 meter per second. Okay, so suppose your body is here, this body is here, and this is 45 meter, and this is your ground. And this body is falling means the body will fall in downward direction always. Okay, if something is falling, then falling means the body is coming in downward direction. Okay, so here initial velocity is equal to 0. Initial velocity is equal to 0. Acceleration is equal to minus g, because g will be in downward direction always. Okay, acceleration is minus g. Okay, now we can use the equation of motion. We can use the equation of motion here. We have 3 equations of motion. V is equal to u plus at, v is equal to ut plus half at square. Okay. S is equal to ut plus half at square. So we have 3 equations of motion. So which equation of motion I should use here? We have already calculated basically this time. T is equal to under root 2 HYG. Here I have calculated now. There is a body and this body is falling like this. Okay. This body is falling like this. And time taken by the body to reach the ground. So we got this. T is equal to 2 HYG. So okay, so you can apply directly this formula or you can use the equation of motion. Either you can apply this directly this formula. T is equal to 2 HYG. So from here you will get your answer. 2 into 45 by G is given as 10. So 2 into 45 is 90 divided by 10. So this will become 9. And what is the under root of 9? Square root of 9?
Square root 3.
3. 3 second will be your answer. Suppose in exam you do not know this formula. Somehow you have forgotten this formula. So in that case, what you will do? First you will apply this equation. V is equal to U plus AT. First you will write the data. You have the initial velocity 0. You have the acceleration as minus G. You have the displacement as minus 45 meter. Why you are taking minus 45? Because body is going in the downward direction. So displacement will be in downward direction. So first you will use this equation. Not this equation. First we will use this equation. Because we have the displacement S is equal to UT plus half AT square. Why I am using this equation? Because I have the displacement. Okay. I have the displacement. I have the acceleration. So from here I can calculate time. So displacement is minus 45. Initial velocity is 0. Okay. This is T plus half. Acceleration is minus 10. Minus G means minus 10. Na?
Yeah.
Given in the question. T square. So this is minus 45. So this term will become 0. So you can write here 0. And plus this will become 2 5s are 10. This will become minus of 5t square. So basically you have minus 45 minus 5t square, minus and minus cancel out. So t square is equal to 45 by 5. So when you will cancel it out, it will become 9. So t square is equal to 9. So when you will take the under root on both the side, square root on both the side, you will get this 9. What is the under root of 9? You will get 3 seconds. Okay, note down. Take the screenshot.
Okay.
Just a minute. Completed?
Yeah.
Okay.
Okay.
Okay. So
Okay. Okay. Okay.
So there are few points that I want to write. Hmm. Hmm. Okay, so if a body is thrown upwards, then velocity of body at highest point is zero. So if you are the body, if you are throwing a body in upward direction like this, and okay, from here you are throwing a body like this. After that, this body will come in downward direction. So at this highest point, velocity is equal to zero. And you are throwing this body from the ground. Okay. So there is one more point. You are throwing a body from the ground. Okay. And the body first go in upward direction, then then after that in downward direction, and here the body will be at zero velocity. So the time taken by the body from this point to this point, from this point to the highest point, is known as the time of ascent. Is known as the, so I am writing here, time taken by body to reach highest point this is your highest point. Time taken by body to reach highest point from ground is known as time of ascent. Okay, so this is the point. And time taken by body to reach the ground means from the highest point to the ground, the time taken by the body will be the time of descent. Time taken by the body to reach the ground from highest point is known as time of descent. So these 2 points you should remember. Okay, so take the screenshot. Okay, so
Okay, then.
so if you have any doubt, then you can ask me. Means
No, I don't.
regarding this. Okay. So in school, which chapter is going? Forces.
Yeah.
So you have not told me which book.
Uh, yeah, I told you the book.
Hmm?
I told you the book. I have it
What?
with me.
Hmm?
I have it with me. Called Physics MYP by Concept Year 4 and 5.
Hmm. Do you have the PDF of this or not?
I don't have the PDF though. It's not in the book. Usually they give a PDF, but I don't think this one has it.
Okay, so okay, so that's all for today.
Yes, sir.
And what is the name? Just tell me the spelling once.
Physics
Mm-hmm.
MYP by Concept. Year
MY
4. MYP.
T or P?
PP.
Achha, T.
P, sir. P. Not T, P. P. MYP by Concept. Yeah. Year 4 and 5 Physics.
Year 4 and 5.
Yeah.
This na?
Yeah.
You are in 9th class na?
Yeah.
Okay, no problem.